Okay, so this is the application for linear regression, no? Um, yeah. So let me read the problem statement. So an important tool in correlation of engineering data is the use of dimensional analysis. So this treatment leads to the determination of the independent dimensionless number, which may be important for the particular problem. So linear and nonlinear regression can be very useful in determining the correlation of the dimensionless numbers with the experimental data. So the treatment of heat transfer with the pipe has been considered by Giancouples using the Buckingham method, and the result is that the Nusselt number is to be expected, a function of Reynolds and the Prandtl numbers. Now, as you can see, Nu is the function of Re and Pr. So the typical correlation function suggested by the equation above is, we have the equation 1, as you can see, Nu is equals to A times the Re raised to B times the Pr raised to C, where A, B, and C are parameters that can be determined from the experimental data, again, using linear and nonlinear regression. So, a widely used correlation for heat transfer during turbulent flow in pipes is what we call the Sider-Tate equation. This is just the same with the equation 1, but since you are considering with the turbulent flow, there is an additional variable, which is the ratio, the viscosity ratio, no, of the mean fluid temperature to the wall temperature. So the following table provides reported data for heat transfer external to the 3/4 inch outside diameter tubes, where the dimensionless numbers, the Reynolds Prandtls, the ratio, and the Nusselt have been measured. No, so these are the datas from the experimentation. So these are actual datas. So requirement, okay, use the multiple linear regression to determine the parameter values of the functional form of equations 1 and 2 that represent the data of the table above. The second one would be just repeat the solution from the A, but instead using the nonlinear regression. So maybe on the earlier video, no, I haven't introduced the linear and nonlinear regression, but um, that that particular method will be yeah, it's ideal to explain it through yeah, solving, no, with this problem. So and we could compare easily between linear and nonlinear regression. So uh any of the two can be useful in such a way. Just the same with the roots of finding equation. This too has pros and cons. So the linear regression is ideal for polynomial equation or simpler equations. For exponential functions, no, equations that that has exponents, no, kanang na exponent terms. So much probably ang useful ana is nonlinear regression. And we could see it here, since the equation given are exponential function, we could see the difference between the linear and the nonlinear regression. So let's start solving. So we already copied the given table, no? So ako na siyang translate to Excel for para mas dali ta. So I'll be just writing the given, so the table, and the two equations, no? So for linear regression, The equation 1 would be NU is equals to A times the frontal to, Reynolds pala. Reynolds to the power of B times the frontal to the power of C. The second equation would be Nusselt is equals to A times the Reynolds to the power of B frontal to the power of C, and the mean or the viscosity ratio to the power of D. So, atong second equation, is ABCD. For equation 1 is just ABC. We did not copy the value of the original coefficient. Uh, yeah, for the sake of finding the coefficient out from the given experimental data, and just to see kung unsa siya kaduol sa Sider-Tate equation sa atong nakuha, no, because we will get our own coefficient out from this experimental data. Okay, so okay, again, I already copied this one, and para mas dali. Okay, so again, requirement na to first is A, B, C, and D using linear regression. Second would be A, B, C, and D using non-linear regression. Okay, and so ang kaning table, no, nakihatag, these are experimental data. So let's just say we could term the Nusselt here as our actual data. Kay ikuha siya using an instrument, using the tools, no, for experimentation. And we have here another equation, another data for Reynolds, the frontals, and the viscosity ratio. And maybe if we don't have a tool for solving the Nusselt, we could use the following formula, no, sa kani. So might as well dapat ang iyahang data should be closer to the actual. So is uh that is the path that we are trying to do, no, the A and the B and the C would be numbers that should be closer to the actual value of the Nusselt number. So by equation, no, let's start with the equation 1. Our Nusselt number is equals to, we'll be clicking the A portion here. So wala sa tayo value first. Times the Reynolds number raised to the B times parenthesis the frontal raised to the C. And I will be adding dollars so that the values are locked, no? So we could drag this one, no? Because repetitively man siya. So expected that it would be 0 because wala pa tayo value sa ABC. And yeah, the residual should be the difference between the actual and the predicted. So it should be this one, equal this one minus this one. And yeah, we didn't have to drag the host. So yeah, And we will square this one. So square, we will just drag this, and we will take the SSR, so the sum of the square of the residual, no? Literally, sum of the square. So, muna, SSR ang term niya. So, the sum, and we have the value of it. So, yeah, by using this type of, by establishing this type of data, we could find the ABC by using the solver method. So, how? In the data column, there is what you call the solver method here. As you can see, you could, if there is no solver method, you could find it in the option, then add-ins, then Excel add-ins, then go, then make sure solver add-in is checked, then okay. So, kanara. So, again, date solver feature is in the data in the data tab. Click that one and set objective. So what we are trying to aim is that our sum of the square of the residual should be at the minimum. It should be the least minimum errors, no? Mama na ang residuals. Those are errors and should be taken to minimum. And we need to change the values for the ABC. So I will be dragging this one. So nagsobra kog usa, which I think there is a problem with the solver method. It will create 0 to your C if I don't add another dummy space. So ako iana lang na siya nato ha. Then make unconstrained variables for non-negative, then GRJ linear ang ato ang algorithm for solving. So what is the solver parameter is doing, or the solver method is doing, is that it will create a trial and error, so that what happens now is that the solve predicted should be closer to the one for the actual values. So ato lang ni i solve. Okay. And okay. So you have here the values now for your A, B, and C. So look at it. So gikan sa actual and the predicted, and you have at least much closer values, no, for every equation, for every values of the Reynolds and the frontal. So yeah, and you could rewrite this one, no? You could you could have your equation out from the first solution, no? Which is that is 0.0.27866. Then ang B na to is 0.618255. Then sa C is 0.31444. Bigyan na lang siya. So that is for, yeah, equation 1. And let's proceed with the equation 2, the Sider Tate. Okay, again, I will be just repeating the method. So ako lang ni i-copy. Ni siya, ako lang ni siyang ipang-move. So this should be Reynolds, should be frontal. Kani siya, kani siyang i-move. Very. Okay. residuals, this should be, again, you could drag this one and have your or the SSR. Okay. Okay. So again, use solver method to find ABCD. So set the SSR to minimum by changing A, B, C, D, then plus the dummy space. Then yeah, then solve. Okay. Yeah. Sayop. So you should at least delete. Should have at least add no napaday ni viscosity ratio. So this is um A times Reynolds to the power of B times frontal to the power of C times the viscosity ratio to the power of your D. So ako po ning i-dollar sign. Ayun, lock. And then solving again by using solver method. Okay. So set the SSR to minimum. So sakto na siya. Ilang balikan. Okay. Then by changing the values of your A, B, C, D, and plus the dummy space, and wala na, sakto na ng settings, then solve. Okay. Pero zero gihapon siya no. Balik mo daw natatali. Okay. Let's just be sure no na delete siya zero. Okay, so this should be A times the Reynolds to the power of B times times open parenthesis the frontal to the power of C times the viscosity ratio to the power of D. Then lock the values so sa A, B, C, D. Locking. Then residuals should be equivalent to the actual minus the predicted. And this should be the square of the residual. Then you could drag this one and you could have the sum of the square of the residuals. And lastly, applying the solver method to set the SSR to minimum by changing the variable cells of A, B, C, D. Okay, then solve. So, 0 gid siya, no? So, what if we set this one to 0.1? Then, applying solver method to set the minimum by changing this one. And solve. And na siya values. Like siya How about wala pizza? Ano ba na? Sorry mo dependent mo gud siya. Again, over method, changing this one. Minimum. Anyway, mag-zero magit siya, no? Kung muna tag 0.14 kay 0.14 man to siya. Then, again, ano siya. So let's just try this one. Okay, so this is the first equation and this is the second equation. So we just plug in the values of A, B, C, and D here. So this is 0.284055. The B is 0.616316, and the C here is 0.320791. The D is 0.062039. So 0.062039. We could grab this one to really compare the result, no? Okay, so let's first grab this. So with respect to Reynolds lang. Okay. Insert line graph. Again, static. This one. Changing. Yeah, kanya lang ko. Anyway, same naman na sila og one. Reynolds or frontal. So actual, then add, no? Let's add the data. So add on data. Yeah, this one. Add. Then series name would be linear equation 1. The value of your y should be any, okay, and let's add again. So linear regression equation 2. Can we, okay, and as you can see, yeah, we have a slight problem here, no? Almost ning fit na siya unta sa actual data pero na discrepancy diri. Comparison of linear and non-linear regression. Okay. Ang guro pag-lection. Yan eh. Sana. Okay. Okay. So, if we proceed with nonlinear regression, so what will happen to the equation is butangan na to siya og ln. Okay, so for changing the solution, for changing the equation based on nonlinear regression, this would be ln of the equation is equals to a ln again ln of a times the Reynolds to b times the frontal to c. So by the rule of logarithmic logarithmic na rule, no, so this is equivalent to ln of nu, which is equivalent to ln of a plus b of ln of re plus c of ln of pr. Then same with the second equation, that is ln of nu is equals to ln of a plus b ln of the Reynolds plus c ln of the frontal plus d ln of the viscosity ratio. So let's do that, no, instead of the original equation. So let's create again a table. So ako na siyang i-drag niya yung ano. So let's copy this one. Okay. So equation sa ato ang first equation sa nonlinear. So that is, we need the ln of nu here. So I will be adding the ln of nu so that we could, yeah, take the residuals, no. So this should be it should be ln actual and the same here for the second equation at wala nang butang ng tao. ini po, dapat ln of n yun na po ni. So, ln, so function for the natural logarithm in Excel. So, take the ln of the actual, enter, good, right? Same with this one. So, that should be ln the actual, again, ln of the actual, and drag this one. Yeah. So lnu of the predicted should be based on the equations that we created. So that should be ln of a equals to ln of a plus the parenthesis b times the ln of the Reynolds, ani, close parenthesis, plus the c times the ln of the front line. Okay. So, error siya no kay wala man tayo values sa ABCD. So, then taking the sum and the receivables, actual minus predicted, and this should be the square. The residual should be this, should be taking the square. Ako lang yung kopya dere. Then natay additional, which is tapos ano yung drag code. Which should be the Reynolds, the frontal, and additional should be the D times the ln yun ang 0 na. Okay, let's do other way, no? Kaya num siya. So, wahaon sa daw nato ang ln sa tulo. So that should be ln of the RE, then ln of TR, then ln of the viscosity ratio. So this should be ln of this one, and ln for the frontal, And for the viscosity ratio, ln, this one. Okay. Then drag this one. Okay. So replacing this one with this one, and with this one. Error day siya kahit tungod sa A. So let's put a value of 0 here. 0 to 0. Let's see. One. Yeah. So at least kana lang. We are just trying to have specific values here. So I think same naman ang idea here. Only a lead on should be this one with this one, and then me should be P times the viscosity ratio. Okay. Ito lang ni siyang pang lock. So, para ma-drag na to. This one. This one. This one. This one. And this one. And lastly, this one. Okay. So, we could drag this. Then solving for the SSR to sum, same here. Then kuhaon na to una ang first equation. So again, solver method, then changing this value to minimum by changing the ABC. Okay, have a value here. And for the second equation, solver method, ayun, changing the value of the SSR here to minimum, and by changing the four values A, B, C, D, and solve, and we have a value. Okay. Okay, so natay LNNU. So para makuha balik ang NU diri, no, para ma-compare na nato, ato lang na siyang i-exponential, no. So NU so equation 1 and this is for equation 2. exponential function for ano then exponential sa equation 2 ano pwede naman ko i-drag so updating the equations. So sa katong nonlinear regression, this is 8.070584. Pardon. 8.070584, then 0.324515, and for the C, that is 0.044786. Then for the second equation, that is 13.3639. Then 0.275111. Then for C, we have 0.078475. Then last one would be 0.490603. Na. So those are the equations that we get out from the method, and let's just have a visualization to compare all of the resulting solution. So at the dere, so nonlinear regression equation 1. Kanino. Okay. Okay. Ito po ni-edit para masaktuhan. Then last one for equation 2. Change values. Okay. Okay. So we could now see the visualization. So let's see. Okay. Based on no, the result, mas ninglayo na noon ang mas ninglayo pa. Ano? Mas dool-dool di ay ang nonlinear regression. As you can see, ano, mas layo di ay no? The blue one is what we called as the kuan man ni the accurate data. So mas ning palayo noon day siya. Mas dako noon ang convergence diri. So, given the situation, mas better di ay ang linear regression. Ang bali na noon, no? So, yeah. So, we could not, ano, this is just the results, no? This is just based on the GRG pod ni na results. So, we cannot blame the algorithm if mo ni ang iyahang results. So, based on the results, yeah, mas better guro ang linear compared to non-linear, no? And these are all the equations, no? These are the predictor equations, no? If we try to have a set of values for the Reynolds and the frontal, then we could use this equation to get for the Nusselt number, based on the original equation and based on the so, um, Sider-Tate equation. Okay? So, inana ang pagsubay o paghimog equation based on tables and based on experimentation. That's it.